Hello, Cheers Kevin here, and welcome back to another episode of Minecraft Agoraphobia. And I think I've been out gathering some resources, and I think we are just about ready to assemble this robot. Now, of course, that does mean that I'm going to have to kind of disappear for a while, because it does take a while for the assembly to actually work. But this is the layout that we've gone with. So built the inventory upgrade. I had to go out and gather some more iron. Tossing a screen and a keyboard into our robot so that we can go ahead and control it. This is still a computer case tier 1, which means this one is going to be a bit of a simpleton. We are running memory tier 1.5 because we can. It doesn't seem to increase the complexity from memory tier 1. I would love to have an available card slot, but we need the graphics card to control the screen. And if we try and put in a card container, then our complexity gets too high. Now, we could combat that by sacrificing RAM, but I feel like that's going to be more of a limiting thing than anything else. So another thing to note, because we are on the computer case tier 1, we don't have all these extra slots and whatnot. We need to install the OS to the hard drive before we boot things up. Otherwise, we're going to have a problem. So let's go ahead and plug this in here. We have our computer right now is a 2-tier computer with the internet card, the graphics card. I suppose actually with the computer tier 2, we could create a graphics card tier 2 and then get a higher resolution screen. That might be something nice to do as well. But I'm going to go ahead and plug this thing in. This one has OpenOS installed already. This one does not. So let's go ahead and boot this up and install to the second one. So we can type install. You can change the text size on screen. So let's try that. Resolution 80, let's see, 8032. No, unsupported resolution. Fine. 4016. Oh, okay. Well, that's fine. Okay, nothing to install. Wait. We need the OS disk. So, yeah, I guess we need to pop down to my storage system to gather that. And speaking of the storage system, we are making progress. I'm going to go ahead and take the fall damage here. Even with feather falling, it's not the most pleasant thing. But I've got this starting to be laid out. Actually, the floppy... Let's see. One thing that I have been doing, though, is basically just in this one, I've kind of just thrown assorted components. So I think, well, we're going to get into this, but I think our robot's going to be in here sorting, filing stuff away. I think the policy that we're going to have is that, hey, if the item that you're carrying happens to match the thing in the top left, then go ahead and throw any of that into any empty slots. But then also, hey, if the item that you're carrying happens to stack with anything that's already in here, go ahead and toss those on. So that we can decide that, hey, there are going to be some containers that we have where we throw multiple types of things, but it won't throw any empty, it'll go ahead and continue to stack basically based on everything that it finds in here. The limiting factor, by the way, as far as finishing out kind of the third row, and I mean, who knows how many rows we'll eventually have, is gathering leather, because I need to AFK at the fish farm to kind of fish up leather. It's a pretty rare drop, so I've used just about everything making those item frames. Eventually, we could go out and find ourselves some cows and stuff, and that'll make life a little bit easier. But okay, so we have that. We need to, install, put that in there, and then install. There we go. Okay, and it's saying, hey, what do you want to install to? I'm going to install to disk number 2. And all that's doing is it's copying a whole bunch of stuff to that drive, which is just fine. You see, it's all of the commands that we run, so list and edit and all of those things, they're actually just Lua scripts that are... I mean, even the shell is a Lua script that's saying, hey, you typed, wget? Well, let me see if there's a program called wget, and I'll go ahead and run that. Once this is done, we can go ahead and take the hard drive out, plop it in here, and then we should be able to assemble our, relatively modest robot. It's really just going to be an archivist, right? It's going to be taking stuff into storage, taking it out of storage, doing whatever. Oh, yes, reboot now, yes, go ahead. And of course, this shouldn't use this, but it now actually hang on a second. Okay, and once I turn it off, it does say that it has OpenOS installed. Good. So let's plop that in. Let's make sure that this still boots just fine. This, yeah, it's gonna find. Yes. Okay. Perfect. And with that, I think it's time to assemble. All right, I think this may be a first for us. We may actually build in the estimated time because we finally seem to have enough power. And I mean, there are definitely sheep down there that are increasing our charge, but we're draining far slower than we are losing. So finally, we have enough to seem to run these assemblers, because basically what was happening before, and I cut this out of the videos, but you know, we would get to 23% or whatever, and then we would just have to wait until there was enough charge to get the next percent done. And okay, so we have Bender the robot. That's a great name for a robot. Let's go ahead and power it on and make sure that it works. Good. Promising. Okay, and we have the tier 2 upgrade slot, so we can go ahead and plop that right in. And of course, this does provide us with the ability to control external inventories, and in addition to swapping tools, but we don't particularly care about swapping tools. So we have an inventory of 16 slots, and we have the ability to pull a whole bunch of stuff in and inspect other inventories. So that's great. I'm going to take Bender downstairs. And now we really just have to think about what we want this program to do. So what we're going to do is we're going to say first, move over to, I don't know, on top of this chest and grab up to your up to as much space as you have in your inventory. Grab that stuff. And once we're done with that, we'll navigate over to here. And I think we'll start. Yeah, I think we'll start at the top. We'll go, we'll check the inventory. And as I said at the beginning, I want to make sure that we have the ability to, share things where it makes sense. So I think the memory actually doesn't stack, which is kind of a bummer. So yeah, I think that the generalizable rule is if anything that already is in the chest, you can either stack more of it onto it, or you can use up some of the empty spaces with other of those items. So if the robot were carrying a memory 1 stick, it's allowed to put that in here. Of course, and even if things were like this. So right now, if it has a memory tier 1 or a memory tier 2 or a hard disk, feel free to chuck those in here. Despite the fact that they don't stack. Ideally, it will stack them if it's a stackable thing. So if we put circuit boards in here, for example, then yeah, it can go ahead and toss those on here. It can also toss them into empty areas. So it's gonna be kind of another simple movement loop in the same way that we have our bot down there doing the feeding the sheep. Let me jump over into the code. I think I'm probably going to just write out the movement commands first, because we already have a library that makes it easy-ish for us to do that. And then we'll code up our actual policies. You know what? Let's go ahead and just do this sort of live together. And I can fill in, we'll leave functions or spaces where I can fill in the movement commands later. Let's first move our test.lua to... let's see, power station.lua. I don't know what we're going to call this thing, but whatever. Just so that it's out of the way. Actually, what I should have done is just done the same thing, but said git move that. All right, now it's going to be mad because that's not where it's supposed to be. Yeah, okay. Now it'll stage that migration that says, hey, you renamed this thing. Cool. Okay, so let's create another one called storage.lua, and I'm going to go in here and copy our move function, because I think that is useful. Now, one thing, though, to point out is that, let's see, we can go ahead and copy all 3 of these, too, because we're going to need to manage our inventory, we're going to need to know about the sides, and we're going to need to know about the robot. One thing to mention is that we could use different functions. Require Robot provides a different API than just what we, there's a lower level version of the robot API, which basically just gives us robot.move. And if we did have these things running on the EEPROM, running as part of the BIOS, we wouldn't have access to things like turn left. I think there's like a rotate and you pass it a direction of whether it's left and right, or a Boolean for left, and so true for left and false for right, or things like that. We could eventually upgrade this move function to be a little simpler rather than relying on that interface that's exposed to us. But okay, let's, you know what? Let me do it real quick. Let's launch a browser, and I want to check. Yeah, no, don't care. Lua function hoisting. Just because I want to see if this is a thing. Let's see. That's an obvious point. Hoisted. JavaScript functions are hoisted. They can be declared in any order. Lua. Okay, so yeah. Variables must be declared before use. Forward declaration. Let's see. Forward defined function. List dynamic and values that are blah. Don't need forward declaration. Just make sure it's in scope. Global variables, global environments, the default place to look. Yeah. Oh, you know what? That shouldn't be an issue. Assuming, yeah, okay. That's all. Okay. So the thing that I was worried about is, hey, if we refer to this move function up here, is that going to cause a problem because it doesn't know about the move function yet? In a lot of languages, they will basically extract all of these definitions and throw them at the very top so you can put things in whatever order. I think we should be fine. So if we were to write move here, it would throw an error. But if we write main here, if we create a function main, and this lets me structure things more in the way that I would like to, and go ahead and say move. And that should be fine because it's not going to run or evaluate stuff in here. We'll just make sure to run main at the very bottom. Just to test that, let's create a hello function just to verify that. We'll say print hello. And if we run hello in here, let's Lua this file. Module robot not found. Right. Fine. Okay, so that it does say hello, but if we tried to call hello outside of here, then it's going to get confused. Yeah, it's going to say, hey, I don't know what hello is. Okay, cool. So then we are just fine. Okay, so our main function will be up here, and this is going to define everything that we're going to do. We're not going to be running a lot of this stuff, I suppose, in this environment. We'll have to copy it all over. But first thing to do is to go to pickup chest. That'll be a function we'll have to define. Then we will, let's see, what are we going to do? Pull, let's see, fill inventory. So we're going to get everything out of the chest that we can possibly fit. Seems reasonable enough. Then we're going to go to first storage chest. And these movement commands are ones that I'll probably fill out off camera, just because I did ask you guys, and you generally seem to be in favor of me doing a lot of this coding stuff on camera. I do know that it can get dull after a while, though, so I want to be mindful of showing you guys stuff that's interesting, but not doing stuff that's repetitive or stuff that we've already done. That we could better fill with other things. So okay, we go to the first storage chest, and then we think about the way that things are laid out. We had the first two rows were empty because that's where we're going out. So the room is 14 by 14 because we're taking up, it's a 16 by 16 chunk with walls on all four sides. So that reduces it to 14 by 14. But then we have a gap of 2 because we're not filling the corners. So let's assume that the first storage chest is the bottom left. Well, the leftmost one. Because we have chests around all 3 sides. So that's going to mean 14 minus 4 means that we have 10 rows of chests that we need to process. So for I equals 1 to 10. And actually, just speaking of that, we should open up Power Station. Go refresh that. Power Station, because one of you mentioned, and I forget who mentioned it. We have this for I equals 9. Yeah, replenishing supplies. I had the wrong numbers here. This should be 10 to 18, not 10 to 19. I'm still, yeah, because of these numbers are inclusive. Okay. Anyway, okay, so for 1 to 10, so for this first set of rows, we want to process, let's see, let's just run, start at the top. Yeah, that seems to That seems to make sense to me. So we're going to go to the top row of wherever the chests are. And then we will say, we will process the chest. Process. Let's just say process row, right? Can we do that? Yeah. 1 to 10, process the row, and then robot needs to turn. So once we're done processing the row, once we've gone down the line, then if we just turn to the right, then we're at the beginning of the next line. So perfect. So we'll just move to the right and then do this thing again. And in fact, we should just be able to do exactly this 3 times. So for I equals 1 to 3, and then we'll change this to just J. And I don't know if there is, let's see. So we'll go through, do this, turn to the right, go down the line, turn to the right, go down the line. And then I guess we've turned an extra time, but that's okay. Okay, and then return to charger. Now, the one downside here is that we are currently going to be just keeping everything that we can't find storage for. That'll be stuff that we can deal with in a more advanced version of this script. In the meantime, we can just intercept the robot and steal stuff that it doesn't know how to sort if that becomes an issue. Okay, so let's write out some of these functions. So go to pickup chest, function is that, and end, and that's to do. Function fill inventory, that's to do. We'll do that one together. Function go to first storage chest. That'll be another one I do offline. Process row we'll certainly do together, and then return to charger. That's just more movement stuff. Okay. So fill inventory, we're going to need to say for every, let's see. So we're assuming from on top, assuming we're on top of the chest, we're going to say for each slot, we've got to try and grab it. Yeah, we're gonna be, there are cleverer ways that we could do this. But for I equals 1 up to how much space we have. No, how much space, inventory slots in chest. And there is actual code to do that. We'll worry about that in a sec. So for every inventory slot in the chest, for every, yeah, we're going to do this in a dumb way. For every inventory slot in robot, try and grab it, right? It's stupid. Because presumably if we can fit it, then there's nothing left in the chest, so we can't grab anything, so who cares? But yeah, whatever, it's fine. We can be a little wasteful here, and it keeps the code short, and we don't have to do checking of saying, hey, did we grab it? If there, blah, 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 blah. Let's go ahead and pop up here. Let's open up the Open Computers inventory controller API, the component rather. And okay, so get inventory size is the size of the inventory at the specific size. So that's the external one, and that's the inventory slots in chest that I was referring to. So let's change that word to inv.get inventory size, and we'll do size.down. So this will iterate over every inventory slot in the chest, and then we need our own internal, let's see, inventory size. Let's see, size. Boom. All right, so we don't have our internal storage as part of that API. Let's look at the robot API and see. I think it's available here. Do size. Yeah, robot did inventory sizes, the selectable slots that we have. Okay, so do that. Robot.inventory size. Then, so for each of those, go ahead and try and copy. Let's go back. Go ahead and try and copy, or well, sorry, not copy, suck from slot. So suck from down, and then the slot number into the selected number. So actually, it's two things. We need to select robot.select, and then we give it the current robot slot that we're trying to suck into, and then inventory.suck, suck from slot, sides.down, and inventory slot I. Yeah. And if we don't give it a count, it's going to try and move as many as it possibly can. So we are going to try, for every item in the chest, for every inventory slot that we have, we are going to swap to that inventory slot and try and grab things. Now, I think, I'm reasonably sure about this, that there is some incentive for us to go back and eventually refactor this to something that's more efficient, because it's probably going to use more power, going ahead and trying to grab this stuff over and over and over, even though it doesn't quit when we've already managed to grab all of it. But that's fine. It should at least work. Okay. So we've got that one filled out. Let's move on to the next thing. Well, let's see. To do. We'll just put to-dos in the ones that I'm going to do offline. So go to first storage chest. Again, is just going to be for me to worry about. Okay, process row. Now this assumes we're at the top of the leftmost. I shouldn't have called it row. Let's call it column. Yeah. Because we've got rows. I had the words wrong. Okay, so if we're at the top of the leftmost column, then all we have to do is for I equals 1 to 3, do, let's see, process chest, and then, let's see, and then robot.move down. Now, that's not going to work entirely, because then we'll try and move down at the... it'll be fine. It'll try and move and fail. Suppose we can... So let's see, what would be the better way to do that? Yeah, I guess we'll just do that twice, and then we'll say process chest again. There's I'm sure there's a smarter way to be doing that. So we'll process the first chest, we'll move down, process the second chest, we'll move down, and then we'll process the third chest. And this does assume that we have a column height. Actually, you know what? Let's go ahead and set that. Let's say local column height equals 3, and then, so that's something we can configure. Height -1. There we go. Let's put some parentheses around there just to make things nice and clear. So process the chest, move down, process the chest, move down, process the chest. Then we will move up by, up by column height, -1. Actually, we should probably double check that that works. And then turn to our left, go forward, and then turn to our right. I want to go ahead and just open up a Lua interpreter real quick. So if we say hello ... 5 - 3. Yeah, there we go. Okay, hello 2. Perfect. There we go. All right. And actually, coming to think of this, when we have at our very top loop, yeah, we're not moving. Return. Yeah, I'm sorry, my directions were wrong. So if we're facing the chest, then we need to turn to the right, then move forward, then turn to the left. There we go. Okay. Now, of course, this implies a function that we haven't written yet. Let's go ahead and write that. So that's process chest. And this assumes now that we are standing in front of a chest. Okay. So now the question is, which items are we allowed to put in that chest? And to do that, to figure that out, we're going to say get stack. Let's see, not get stack in internal slot. We'll say, get stack in slot. So this will give us a table describing the item in a specified slot or nil. So we can just get a list of all of the things that exist in that chest, and we'll do that first. So we can say for I equals 1 up to, what was the text for it? Yeah, get inventory size there, except it'll be sides.front this time. So for everything in there, Then, okay. So for everything, then we will say get stack im.get stack in slot and sides front slot I. And what we care about is the name. So we're going to grab the untranslated Minecraft name. So like OC item.floppydisk or Minecraft whatever. And that's great. So .name. But what I want to do is to basically get so some of these are going to be empty. Yeah, so we'll get nil. And that's fine. What I want to do is like a Lua map. Let's see. Lua map. So I want to basically convert these things. Oh, okay. Here we go. Table.insert is what we want. That's easy enough. Okay. So we'll say valid is this table. In Lua, this is the one data structure. It's called a table. It's the same as a hash or a dictionary or other things. So we'll say, okay, so item, let's see, name equals this, and then we'll say if name, then valid, table.insert into valid name. Right. Okay. Let's just double check that that's how we want to do things. So we'll say foo equals this, and then foo.insert or table.insert foo 5, and then table.insert.foo rar. And if we look at foo, okay, is there like a foo.inspect? I don't know. Oh wait, can I just, whoops, equals foo, no, okay, foo 0, oh right, I'm sorry, so that's, yeah, that was my own stupidity. Lua is also 1 indexed and not 0 indexed. Yeah, so the first item in the list is that. Okay, cool, that will work for me. So now we should have this table called valid. My keyboard's being weird. Should have this table called valid that describes everything we're allowed to put in to the thing. Okay, so with that, honestly, the rest of this should be pretty simple. We're going to then go through, we're going to kind of do the reverse of getting stuff out of the chest. Inventories, yeah, so let's just copy this loop here. And actually, well, okay, let's do this first. The only thing that we're going to do is we're going to flip how this works. So we're going to say for every for j equals 1 comma this. So yeah, we're going to say for every slot in the robot's inventory, for every slot in the let's see, sides front. Yeah, no, not sides down, sides front. Okay, so we're going to loop over everything that we're holding, and we're going to say, hey, every possible slot, we're going to try and put things in there. I'm going to select, well, I suppose, yeah, now we can put the select outside here. And then we'll say drop into slot. Let's look at the documentation. Yeah, drop into slot instead of suck from slot. Drop into slot and sides front. And then no, it's J. Right. So we're saying, so basically we select every item in our inventory and we say, hey, every single place in this chest, I'm going to try and put it in there. But that's going to just put everything into the chest. We want to only do it if the item that is in the inventory, if the item that we've currently selected is part of this valid table. So if something, then, and then that, fine. Then that. So this something is whether or not the item that is in our inventory, let's see. So there's a get stack in slot. There's an internal, let's see, get slot, internal slot, get stack in internal slot. Perfect. Okay. So we'll say item or name equals inv.get stack in internal slot. And I don't think we need to even give it, yeah, just the selected slot is the default. So we can say, hey, here's this. Although if there's nothing in there, and maybe name is going to crash. I think name is going to crash in that case. Yeah. Okay, so we'll have to refactor this a little bit. Actually, now I'm wondering. So we have to check whether our table contains that name. But rather than keeping the table as a list, why not just make the table something like valid equals, cobble true and stone true or whatever, and then we can just do lookups that way. Let's test that theory. Foo equals cobble. Well, we can use just plain cobble equals true and stone equals true. And then if I go foo cobble, that's true. If I go foo quartz, it's going to get nil. Okay, yeah, so that's easier than using even table.insert. So we'll say if name, then valid name equals true. Okay, what was I saying though? Okay, so let's say stack is this. Yeah, we're gonna have to have some additional conditions here to make sure that because otherwise we're trying to call .name on nil. So we'll say if stack, then name equals stack.name. And again, probably cleaner ways to do this, but there we go. So we'll grab the thing in the slot, and then we'll say, hey, if there was anything there, then I want to look at the name. And well, actually, we don't need to say if name. Yeah, we can just say valid stack.name equals true. And if we overwrite an existing thing, that's fine too. Okay, I like that. Okay, so if, let's see. So yeah, so we got to rewrite this to be equally, I don't know if I should be using locals and whatnot. I need to look at scoping rules for Lua, but okay. Let's say stack equals inv get stack in internal slot. And then we'll say if stack and valid stack.name. We can just chain those. Then do this, right? That's all that we got to do. So we've examined the slot. We say, hey, if this is a thing we're allowed to use, then so if there is something in our inventory and that thing in our inventory is something we've already decided is valid to put in this chest, then go ahead and try dropping it into absolutely every inventory slot. So again, we're being a little redundant, but I think this should work. Let me go ahead and fill out a bunch of these movement commands, and then I will see you in the game. But I just realized there is no way for me to transfer stuff into here. We didn't put in any sort of disk drive or anything. And it doesn't have an expansion card slot. Oh, you know what? Actually, can we put this in here? No, because that's an upgrade. So we don't have a container for a card, so I can't put anything. I can't get any content to this. It doesn't have an internet card. It doesn't have any of those things. Oh man, that is a bummer. I think what we're going to do then, I mean, I could type all of this in by hand on here, but I think probably better is to disassemble it, and maybe we will actually try assembling a robot without a screen or keyboard, but put in a disk drive. So that should allow us to mess around with it, and then depending on how the complexity looks, we could even potentially put in a wireless card so that it can manage stuff that way. Say hello to Shaky. Shaky has a disk drive and no monitoring keyboard, so in theory we're not going to be able to see any sort of text output or type anything into the robot directly, but that's fine because, hey, we're writing the program and we expect it to just run this program. We should be able to, if there's a big error, I think we should be able to get some information from the analyzer if we need to. I have also put up the third row of chests here just because I don't want it to break for strange reasons. Let's see. Come on. Okay, let's build ourselves a little way to get up there. I do need to make sure not to get in the way of where the robot's going to be, though, so be mindful of that. Also need to make sure that the robot starts facing the right direction, so Let's see. There we go. I've moved the torches up a little bit as well, because it should be going up here and then over before it goes down. Actually, yeah, one thing real quick is that over here, this torch needs to be moved. Let's plop that up there. Probably we'll need some more torch on the floor, but whatever. This is fine for now. I am going to knock out this wall real quick just so that I can place this robot down in the correct orientation, or at least the orientation that it expects. And if we boot this guy up, there we go. Yeah, so no screen, just the inventory. It is booting up, though. You can hear it doing stuff. It has OpenOS installed on the hard... At least I hope it has OpenOS installed on the hard drive. Boop, 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 boop. Okay, and now it should be ready to... I'm going to need to get out of here. There we go. Okay. Shaky, I'm going to put this in, and we're going to see if you happen to do... Actually, you know, before we do that, we should put some materials. I've moved everything out of this chest. We should put some materials into this chest and see if Shaky manages to store them correctly. So, let's see. Buttons seem like a good thing. So we've got one button there. Let's give him some buttons. Let's grab some hoppers, and I'll just leave the one in there to cue it that, hey, these are things you should go ahead and put away. And yeah, no idea if this is going to work, but we'll see in short order. Pop that down there. There we go. Okay. Shaky, are you ready? Let's do it. Well, that's a bummer. Okay. So Shaky is not doing anything. I wonder why that could be. We don't know, but that's okay. We can go ahead and steal our other robot and use that one to actually debug this program. Once we know that the floppy disk has the proper auto-run Lua script, then we should be able to use our headless robot to actually do the sorting and whatnot. Okay, so Kodos, I have a task for you. How are these going, by the way? Oh, we're full there, and we're getting full on... seeds too. We are going to have to figure out a longer term solution to making sure that we don't get the hoppers completely locked up with seeds. But we will get to that when we get to it. Okay, Shaky, you are you are temporarily retired. Robot, let's go here. All right, Kodos, let's boot you up, and let's see what you do. All right, plug this in. Oh. Okay, for some reason, Kodos actually seemed to run the program just fine. So why should that be the case? I mean, that's interesting. All right, well, let's see if the program... Oh, because I think I put the wrong floppy disk in. There we go. Okay, yeah, now you're doing nothing, and you're not saying why. Oh, really? Well, that's not good. Oh, you're off. Never mind. Huh. Okay. Okay, now let's try plugging this in. Oh, okay. Kodos is perfectly happy to do Kodos' job. Comes down here. It's going to grab... Okay, Kodos grabbed everything and is now going to spend an obnoxious amount of time. Yeah, so you can see it's changing the selections. So it's going for every inventory slot. It's trying to put it into all of the... For every chest slot, it's trying to put it into all the inventory slots. That's slow and inefficient. And yeah, I think it's definitely draining. Well, actually, we're not losing energy too much. Oh, I mean, maybe. I don't know. Maybe it's just batched. There are definitely more efficient strategies we could be using. But that's stuff we can clean up later. Kodos, why... I am very curious as to why the other one did not seem to respond. Are you still... All right. Yeah, no, we got a problem here. Okay, so yeah, I screwed up my movement commands because it tried to go forward. We should just go up twice. Yeah. Okay, so going to pick up chest worked just fine. It's the going to the first storage chest that we're going to have to change. So we will go, yeah, it tried to go forward twice. So let's go up by 2, then forward 5, then, yeah, left, and then 5 forward. Then we don't need to do the 2 up there. Although actually, we only need to go up by 1. because we're already raised up by one from the chest. So that should fix that problem. While we are at it, let's adjust this fill inventory thing. Let's see. So for every, let's check first if there is anything in that inventory slot before bothering to try and put it into all of our, in that chest slot before trying to put it into our inventory slot. We have that. Let's see. Stack. Get stack and slot. Yeah. Okay. So we'll go ahead and just say if get stack and slot, then, and we'll change the arguments there so that it makes sense. But if get stack and slot sides down I, then go ahead and try and put it into all of the spaces. So then it's only going to do that twice with that example where we had 2 items in there. It'll be exactly as slow if the chest is all the way full, but whatever, that's fine. Okay, the majority of the cases are going to be going through and finding that we don't have anything in the inventory that matches the chest. 1, 2, 3. Okay, so it took 3 seconds for a chest that it couldn't do anything with. The big test case is whether or not it puts anything in this button chest. And I'm sure this is all stuff we could speed up. Nope, our motion is wrong. Oh, whoops, I have this, I had this backwards. We need to move up the column height, and this is putting this column height on the turn right. So we would turn right 3 times instead of, okay. I just had this thing completely backwards, and the question is it going to make it to the next column successfully? If so, then hooray. If not, then we may be in trouble. Go. Yes, okay. 1, 2, 3. Okay, good. It is processing these columns, and it should not have put anything in any of these because it's not allowed to. That's all right. And now the test is, will it put buttons in here? So it's going to create the list of valid things to put in the crate, and once it does that, it's going to then it's going to go through its own inventory and try and put the things it's allowed. It did. Yes. Perfect. Okay. Okay, so now if I'm thinking about this right, it is going to have 2 failed movements because it's going to try and go over to the next column before it breaks out of that loop. Not the end of the world. It's just going to fail. Yep, fail and turn. And now it turns, and now it starts on this column. Because that inner loop of processing that wall, it just was... It assumed, or going from the end of processing a column is going up and moving to the next one, which of course we didn't need to do in that case. Okay, so we still have the hoppers in our inventory, and I'm hoping, I mean, there's no reason it shouldn't. If it worked in the one case, it should work here too. It should go ahead and store away our hoppers, and that'll be fantastic news. Let's see. You done? Come on. Perfect. All right. So this robot works, and actually, while I was sitting here, it occurred to me why this thing isn't working. Why Shaky isn't working, and that's because we didn't plug the inventory control upgrade into it, and so that script is going to fail because it's going to say, hey, I don't have that component, and of course there's no way for us to know that because we don't have the screen on it. But once this completes its round, once CODIS is finished and we verify that there's nothing wrong with the pathing all the way back, actually there is going to be something wrong with the pathing all the way back because because I planned on it only going out to here, I still counted... Yeah, the movement back, I still have it moving 13. Well, actually, that shouldn't break anything. Never mind. It should be fine. We'll just bang our head against the wall twice before going down into the charger. I am curious how we're doing on power. Okay, so not too bad. And honestly, I don't think it would... Yeah, it didn't take too much longer to process the chest where we actually did have stuff, so I think we are more than what we're able to handle battery life-wise. And you can see how it goes through... Yeah, so it's scanning through the whole thing, and it's scanning through the chest first. That's when it pauses. Okay, so now it's going there. It's going like that. It's going up. Oh, no. Okay, I had it going up too much. Oh, right, because it already went up before, so it didn't make it quite back to the charger. But that's okay. Let's test real quick. If once we put the proper upgrade in this spot, which is... the inventory controller upgrade. That's why we have that whole slot in the first place. If we can get it to run off of this floppy correctly. Okay, wait for it to boot up. It has booted, and boom. And there we go. Okay, perfect. So our other robot is perfectly capable of running this. I just got to fix up some movement, and we should be all set. So I will go ahead and do this. Since it's just a matter of fixing up some movement pathing commands, I will go ahead and fix it up off camera. But I think that is going to do it for us today. It's always a challenge doing these programming heavy episodes because you never know how long they're going to end up being. But I hope you have a fantastic weekend. Let me know what we should be focusing on next, and I will see you next time. Cheers.